response video to Hythloday. Did a decent enough video here. So I'll just go through some of the points, and I don't think I'll need to play any of it. Alright, so he starts off with not ready for prime time, maximize the benefit of whatever, making this argument. Yeah, well, that's the problem with it, right? I mean, if it was just one element of physics I was dealing with, right? If it wasn't a unification type theory, then maybe I could say, well, maybe I'll just do the gravity element, or maybe I'll just do the magnetism element, or maybe I'll just do the, the time dilation element. Right? I could take any one of those and just get into the specialty, so to speak, and get into all the experiments relevant to that subject and do all that. But that's really not the truth. It is a unificating theory. So, yeah, what do you want me to do? Wait 10 years? I mean, I could do the Darwin thing and wait and wait and wait. But why? I mean, I've been doing YouTube videos forever. I've been sort of just living as I live. I've been videoing it, so to speak. So it seems just a natural process. If somebody doesn't like it, well, what can I say? Too bad. I'm just saying there's plenty of room, I think, for a fair cop kind of analysis as a possible theory. And I'm just saying that's sort of the test, isn't it? Because, like I said, this has the element. It has an element in it, the Lesage theory, that's 200 years old. Okay, I mean, we both came up with the same kind of observation that particles make more sense, and that wasn't fairly treated. So I guess that'll be the argument. Let's see if science can give it another chance. Let's see if they can treat it fair. Treat the truth fair. Well, anyway, but whatever. Again, and we're. This is also about this idea of what am I describing? I'm describing causes, not effects. So, I mean, even a lot of this isn't going to be terribly relevant. I mean, in a sense, I could argue that I don't have to disprove some of Einstein's math, just because the math itself disproves itself, because it's so obtuse and impossible that one could argue that there's way too much room for bullshit in there. You can't follow along. You can't understand it as an abstraction. You can't understand what it's comparing to what and what it's multiplying by what for what purpose. You can't follow along rationally. So I'd almost argue that I'm not the one that has to prove something there. That to me is pretty unproven math. And if that's all they have is the math, that ain't enough. Alright, so he suggested that I should pay somebody to interview. Well, that's fine. I suppose, but I don't know if that's to my purposes. I mean, it can be your opinion that that's a good strategy. I don't mind interviewing physicists, and I would love to be able to inquire, to the depth of their understanding or why they believe something and how much of their belief is based on some assumption. They never really saw a wavelength of light. Somebody left a comment about that, but I'll get the comments on my video, I guess, in a different video. But it's even that whole idea. I could just simply say, well, where is the wavelength in the math? When the math wants a wavelength, it just wants a distance. It doesn't say anything about this. This isn't what it puts in the math. It doesn't put any curvy line in the math. It doesn't put a longer line in the math. It puts the distance between one photon and another, not a length of waving. So that's kind of bullshit. Yeah, I mean, just the idea that we assume the existence of this quality, yet we'll find no picture of it. And the only place you'll see it is after it's already had its effect. Now I'm going to make the argument for it. Well, I'll go ahead and say it. If I throw a brick into a lake, and the waves shoot out from the lake, did the brick have the wavelength? I don't think so. So, I mean, obviously, we can only see photons based on how they interact with electrons, and electrons are the things held in tension. They're the things connecting to each other with tendrils of tension. Alright, anyway, so he did bring up the fake Dr. Quantum thing, and he thought the distinction was the fact that they did it with electrons. I don't think that means too much. I just think the significant element of it was this whole idea that somehow photons are changing their behavior based on whether we're watching them and all that kind of nonsense. It was just horrible. Not clear falsifiable claims. Well, I mean, this is another part where I don't get you people. Okay? I mean, I'm making pretty explicit declarations. It's essentially like I'm saying gravity's made out of bird shit. Now, if I said gravity was actually made out of bird shit, you could say something like, well, where's the calcium? And, you know, how come it doesn't smell? And, you know, the obvious things would come to mind. So it's not like this claim has preposterous elements in it. No, it has very, you know, it has a lot of cohesion to the existing evidence as even common people know it. And I would argue that it has connection to the more complex evidence of real experiments, the real data of experiments. So I don't know what I can say to you about this falsifiable claim, in the sense that I have made some predictions. Like, it's certainly falsifiable to, if I say there's no Heisenberg principle, that photons are in a place, they're not on any probability wave bullshit. That's only a function of our inability to see them. So that's the limitation. And so I've argued I could do the two-slit experiment with aimed photons, just do them exactly in a random pattern, and I will create the same phenomenon. So I will know exactly where the photons went, exactly their path, and I'll still have a two-slit wave pattern on the target. That's a falsifiable claim, correct? Alright. Next. I am falsifying their... Oh, yeah, so part of this is that I'm falsifying their claims. I'm claiming their idea of a single photon is nonsense. Their idea that the photon has a wave function is nonsense. I'm saying their idea that... what else do they say about photons? Probability thingy, nonsense. Even spin, nonsense, I think. What else? Alright, so I'm obviously saying the time dilation in space is nonsense. I'm saying there's absolute velocity, not relative velocity. So I'm making lots of claims about their claims. They're claiming stuff, and I think they're claiming it without evidence. So I'm falsifying their claims. In a sense, partially. Alright, simplify. So they said there's two ways to have a qualified theory. It simplifies the current model, or it makes predictions that are in contradiction to the existing model. And that's fine. Again, the bottom line is I don't know if it has to be a simplified model. It could be a more inclusive model. So it could be a more complex model, but it includes more elements of the function. So I'd certainly say that I win on the more inclusive element. I'd certainly say that I'm pretty sure it's simpler. You know, it's certainly simpler than all the, you know, the ghosts they've been creating in their super colliders. Anyway. Alright, yes, this is a list of the predictions here. I just put them in here for the hell of it. So the time, there's no space-time. Of space-time. I don't know why I put that there. No, I'm sorry, trying to read my own writing. Big baloney of space-time, maybe. I don't know. Yeah. No relativity. Velocity is absolute. Let's see, no Heisenberg principle, no real Heisenberg principle, just a practical one. No wave, and no entanglement, nonsense. No faster than light travel. He does mention, we're just on faster than light, he does at the end of the video mention something about some kind of reason why I should believe in some sort of variable speed in the fundamental particles, and I would argue that no, that's based on the idea that this kinetic system doesn't really work if you have variable speed. So if you can have variable speeds, then you can have exchanges of energy. So the whole point is that in a closed system, where I'm going to argue that all motion already exists, you can't exchange energy. You can only exchange direction. That's a really critical part of this whole thing. It's really important. So instead of it's being about information, as Susskind would say, it's about direction. Direction is the information. And the universe, the particles in the universe, are just exchanging directional information. That's it. That's pretty good. I think that's a simplifier. Yeah. Alright, so now we're back to the philosophy, he calls it, in science. I don't know if I'd use the word philosophy to describe science, but obviously there's elements of science that can't be done with real laboratory equipment. You have to do them with abstractions and ideas. So I guess there's some philosophy involved, but it's still a very mechanical philosophy, I would think. I think the real problem is assumptions, and you know, making hard assumptions too early. We're all guilty of that potential. You know, math versus truth, you know, that's a problem. And so I guess I would say something, probably on page 2, but I'll say it here too. Really, problem with math is that math is, as wonderfully explicit as math seems to be, you can understand math in different ways. You can get to the mathematical solution through different mathematical formulas using the same exact variables. You can draw a different triangle. You can use different geometry. So I could talk about pi and say pi is the number that is the relationship between the the diameter of a circle and its circumference, the radius, but it's the same as diameter. You know, just whatever. Same. See, that's even that. It's an example, right? I could still come up with a pi number by just using the diameter and mathematically abstracting it. Or I could use the white space that's created when you make a square around a perfect circle, and use that white space that's in the square but not in the circle, and use that as the formula to describe a circumference. So there's lots of ways to getting to the circumference. That's the trick with math, and that would be my argument in the two, is what quantum mechanics has failed to be explicit about, is the math that's the portion of the math that's adding the wave function is the portion of the math dependent on what the electrons are doing, not what the photons are doing. So anyway, not enough math can be, so I'm just saying math can be adjusted to purpose, and that's where it gets a little bit dangerous. So I'm sure that, I mean, I still haven't found a really good, I mean, this whole, you know, people talk about this predictive value of quantum mechanics and all this crap, and I mean, the formulas are all changed, they're all different. So in a sense, I mean, if I want to just know what the probability is, you know, I mean, you have to isolate a certain circumstance and just do the probability for that one circumstance. You know, you don't, it's like you can't just show the two-slit experiment and then say, give me the pattern on the wall as a mathematical equation. You're just going to end up with a bunch of mathematical equations. And that's, in my opinion, you know, that's where you just choose what triangle gets you to that answer. I mean, it's sort of like you already know what the answer is you want, and then you can find geometry to match it. And so that's just, I mean, I don't want to resort to that. I want to come up with some mathematical manipulation or formula that has in it an explicit component, you know, describing the fact that there is this relationship between matter and photons, and have that described in some way, rather than this, like I said, it just depends on how you draw the triangles. Inverse square law, so you brought that up. I said I was going to play that part, because it's sort of interesting, but I won't bother. He called it a theory, and I thought that was funny, just because, no, it's a fact. I mean, the inverse square law is a fact. It's not a theory. It's an observed fact. And you know, coincidentally, I mean, one of the things that was really even 200 years ago that was good about this shadow gravity idea was that it perfectly matches the inverse square law. And so for magnetism it gets a little more complicated, and I won't go into a whole long thing about it. But you can imagine that for the attractive force, okay, you could sort of understand that the further away you go, the more you would now be letting real gravity in, right? So you have a low pressure force between the two magnets, a no pressure force essentially. And what's happening then when you start separating the magnets, what starts happening is you're creating opportunity for gravity to get in. It all travels in straight lines, so it can't get in when they're really close. There's no way to hit the surfaces. But as soon as you start separating the magnets, you start letting real gravity in, and so that creates your inverse. And then for the repulsive force, it's kind of more like the shadow effect, in the sense the further away you get, the more of the force you're missing, because it's coming out at all kinds of angles. So the closer the two magnets, the angles keep hitting the other magnet because it's close, but the further away they get, then the gravity shoots off and misses the other magnet, so the force is reduced. So it matches inverse square. So it's not a problem. Alright, so then we're on to nuclear. Oh, okay, so yeah, he hadn't seen the new video I did, I don't think, so we'll cut him slack on that, because I think I do mention in the new video that I think the origins of magnetism are in the nuclear forces. And I think that's, but he just describes them as being complex, and then he mentioned electricity. And I haven't messed too much with electricity yet, because, you know, it's nuanced. Because you think about electrons moving, but part of me thinks that what electrons are really doing is transferring their photons to each other. So they're just conveying the bundle to each other. So they're just heavier electrons essentially at one end of a pole and another end. The electrons themselves might not be doing the migrating, they're just migrating a bundle of photons, a weight of photons. But it doesn't really matter. It's obviously the connection between electricity and magnetism is electricity is a explosion of particles. You know, it's a breaking down of the mechanism. You can sort of see it in the sense that, you know, electricity creates light. It does lots of things where you can see that it's breaking bonds and breaking structure, and it's just because there's these magnetic forces are competing with other magnetic forces, and it has to go one way or it has to go the other way, and whatever way it goes, it's going to break tension, and whenever tension's broken, it's going to leave split ends that will create energy. Yeah. So, but yeah, I haven't gone really deep into electricity yet, but I think it's not going to be, it's the expression of velocity. So it's another one of these velocity arguments. It's just a movement, and a conveying of directional information. Motor spins in turbine, motor spins in house. You know, it's a conveying of directional movement. Not movement. It's a conveying of directional change. Information. Simple. Directional information. Just remember that. Anyway, but yeah, I do have to go into electricity more. I'm just not there yet. Conceptually, I have to. Electricity is really, it's involved in so many things, and it's just so, you know, the difference between static electricity and wire electricity and all the different forms it takes, and you know, it's just going to take a little work to get that one. But it has to do with this whole magnetic pole thing, and why do magnets are even created? So, you know, and if the flow of electricity is just really an expression of the easy transmission of photons through a material. I mean, that defines a conductor, essentially. Alright, yeah, so I just added the words adding nuance. So he sort of made an argument that there's you know, you're just going to keep adding on. Well, yeah, I kind of will keep adding on, because it's a very deep subject, all of physics, and what I'm saying is relevant to all of physics. So I'm going to have to keep adding nuance and improvement and specific arguments. Photons not something nuclear forces. Photons not well, I don't know. Not something. But anyway. Yeah, well, I'll get to that next time. Alright, so this is where he said that the speed of light has a truth, and so yeah, I've already said that it's sort of fundamental to this idea of a real kinetic exchange. You really can't have things. It's like in my school of fish argument. The given in the argument is that the fish never change speed. I mean, the whole thing doesn't work if you can change their speed. Running before I walk. Whatever. Change more of the photons. Change non-difference of explicit language. Oh, change the name of photons. Yeah, I'd like to, but you know, this is because you got to deal with the language you got, so I don't know how exactly to fix it. I've noticed in a couple of videos where I've said the word electron when I meant photon, but I mean all the physicists do that. So that's just a trap you're in, you know, is that the words are a lot alike, and I mean adding graviton is going to just make it worse probably, but I don't know, it's such a different word, and that one might be easier not to mess up. But anyway, I mean, this is just the language we've got. I don't know how to fix it exactly. Maybe I can come up with another word, but I just don't know if it's a good idea. Alright, then at the end, he ended with the kind of a fail argument of the Hadron Collider. And he said, I've been falsified, essentially, because they made a proton go 99% of the speed of light. Well, my argument to you would be, if they can show me a picture of that proton still in one piece, going 99% of the speed of light, if they can show me a picture of it, yeah, I might believe them. But my argument is they can't slow that. If they tried to slow that proton down, like let it get up to 99% of the speed of light and then just slow it down, when they get to the finish line, there ain't going to be no proton. There's going to be energy, because they already converted it into energy. So my argument would be, yes, it's a school of fish, and if you accelerate it to these speeds, you'll end up with still a lot of fish, but they're not a school anymore. So I'm just saying, it's the energy of a proton. It's not a proton that they're colliding into stuff. They're not called atom smashers for no reason. I mean, they're smashing the atoms before they even start the thing. I mean, just the accelerating process is already smashing the particles. They're going to smash into something. It's just their assumption that these particles are endurable. And they have no evidence that the particle maintains its integrity through the process of acceleration. If E equals mc squared, how are they going to know whether the proton is a particle or a packet of energy when it collides? How are they going to know? No, that's right, they're not going to. So yeah, I'm not too big on atom smashers as a source of knowledge. I'm sure that they have some benefits, especially with understanding electricity and atoms, and there's other things that I think they're valuable for, but I just don't think people should draw conclusions that particles that exist for microseconds in a circumstance where they just smashed a Cadillac into a Volkswagen, that you should draw a lot of conclusions based on what kind of parts fly off about how atoms are made. So I don't think that's the best way to find out. I could smash a cockroach with a hammer. It's probably not the best dissection technique, right? I mean, I could draw some conclusions based on what kind of colored crap pops out and what kind of things fly off. But am I really going to get a great idea of what a cockroach is I don't think so. So I'm just saying that I obviously can't disprove, you know, hadron colliders, but frankly, I don't think they prove much. They're nice sources of interesting data, but I just don't think people should be taking it to the bank. Yeah. So anyway, so I guess I am saying the Standard Model is crap. Yeah, I don't think it's as complex as they have it wired. Time will tell on that one, right? I mean, I don't really care. Okay, so my unification theory, personally, I would argue, isn't dependent on me giving you a diagram of the guts of an atom. I don't need to do that. I just need to establish the fact that we know what atoms do, which is they exchange photons. They interact with photons. And that's all I really care about. I don't really care about the internal dynamics. I care, you know, I'm interested. But I'm just saying I don't have to go inside the atom to make my argument about what's created the universe, how the universe created. How the universe created. I like that. Yeah, it created. Yeah, it seems so obvious. Creatorism. No, that doesn't sound good. But anyway, so that's enough. So, you know, thanks, I guess. Like I said, I like the critical critiques. I like people who even post stupid links to stupid crap about what something, they claim something's proved by some sort of experiment. But obviously I can't go dissect every experiment physics has done and point out how they got it wrong. You know, that takes a lot of work to go through the entire, all this experimental apparatus and say, well, this is, you know, even doing the two-slit experiment we can't do decisively. And that's a 100-year-old cardboard experiment. So I'm just saying some of these experiments I'm not going to have any, I don't really have the time, certainly not. I don't even know if I have the competence to take on some of the instrumentality being used. I mean, you know, I've made this point before, but if you look at the detector at the Hadron Collider, I mean, it's 10 tons of televisions on top of radios, on top of televisions, on top of cameras, on top of, you know, microwave ovens, on top of refrigerators. I mean, it's a big, giant blob of technology that's dependent on technology, that's dependent on technology, that's dependent on technology, that's dependent on technology. It's like oscilloscopes talking to oscilloscopes, talking to a TV, talking to a toaster, talking to a TV. I mean, yeah, to go through all that to say, oh, well, there's your error. Toasters don't speak blender. You can't take the result from the blender and shove it into the toaster. You got to bounce it off the microwave oven before you go back to the toaster. The microwave oven can talk toaster, so tell the microwave oven and then go to the toaster, and then this will work. I mean, I don't got time to do that shit. Yeah, there's no way I don't have time to get a physics degree and multiple disciplines and be able to point out how their equipment is a little bit buggy. Anyway, till next time.